Good morning, students. Welcome back to science class on the chapter Gravitation. In the previous class, we had discussed some problems. Okay, so today we shall start. We shall study thrust and pressure. Okay, uh, you know, we use knives for cutting vegetables. Okay, in that knife you can see one side is blunt, another side is sharp edges. And if you take a nail, okay, at one side it is very sharp. Okay, and camels can walk. Camels can walk easily on the deserts, but we can't. Okay, so do you know why? Do you know answers for this question? Why the knives edges and nails edges are sharp, and why camels can easily walk on the deserts? So if you know the answer, please put it in your comment box. Quick, I'll give you 2 minutes time. So why knives have sharp edges? Okay, and you will take so for example bullet pins, drawing pins. Okay, so there also one side is very sharp, correct, another side it is blunt. Okay, yes, and now tell me if you know the answer, please. I'll wait for 2 minutes. Quick. Yes, and no one is commenting. Quick. Why? Knives edges are very sharp. You know, truck, correct? Those tires are very wide and compared to your bike tires. Say for a truck we can't use bike tires. Okay, we have to use very large tires, correct? Because those tires they will cover more area, but bike tires cover less area. Okay, yes sir. See here, why the knives edges are very sharp? See, see, just imagine this is a nail, okay? Just imagine. Just imagine this is a nail, okay? See here, this side is it is very sharp, and here this side it is blunt. See here, you are applying force like this, okay? You are applying force here, clear? And take one more nail. So one side is blunt. Just when this side is blunt. Okay. See, here also you are applying same amount of force. Here also you are applying, just when you are applying the same amount of force. Okay. So it drives which move inside. For example, here wood is there. Okay. This is the wood. Okay. So easily this nail it will drive into the wood. Okay. This nail easily it will move. Here you are applying same amount of force over here and here, but only this nail which move inside the hood or which drives into the hood. But what about this one? See here you are applying the same amount of force. Okay, here you are applying the same amount of force, but only this nail which will move inside the wood, but this one not. Why? Why? Because here the pressure is more and here the pressure is less. Why? Because see here this nail, this edge is very sharp, right? Which means it covers less area. It covers less area. But what about this one? This see edge of this side it is blunt, which means it covers more area. Clear? So it covers more area, it covers less area, so that's why it will move into the wood. Clear? For example, uh, See here, if you just imagine you are standing on a sand. Okay, see, if you stand like this, then you will move a little bit, you can feel you are moving inside the sand. But if you lie down or if you sit, at that time you can't. Why? Because see, when you lie over that sand, see, the force from your body is the same. The force from your body is the same. If you stand, if you sit, or if you lie like that. Okay. See, when you lie, the force from your body, which is same. But when you lie over the sand, at that time you will cover more area. You will cover more area. When you stand, at that time also you will cover more. Sorry, when you sit, at that time also you will cover more area. But when you stand, at that time you will cover less area. Okay, see, when you sit, okay, at that time, see, the force from your body is same when you stand, when you sit, correct? When you sit, at that time the force from your body that is equal to when you stand. Okay, but when you sit, when you sit on the sand, at that time your body, it will cover more area. It will cover more area. That see, that pressure is distributes over that area. But when you stand, at that time your body, see, your feet only your feet cover less amount of area, correct? So the entire force from your body, it should move through your feet, right? Correct. So here, why the same answer here also? Here the nail which covers less area and this covers more area, so that is why here pressure is more and here pressure is less. Okay, and if you take knives, okay, knife, that one edge is very sharp, another edge is blunt. Why? You know that sharp edge, see, if you cut see, you can't cut the vegetables using that blunt side. See here, just imagine you are cutting that vegetable using blunt side. They say at that time also you are applying same amount of force. If you use sharp edge, at that time also you will apply same amount of force. But when you use that sharp side, then only you can cut the vegetables. So using blunt side, you can't cut the vegetables. Why? Because see here, that sharp edge, it covers less area. Then at that time the pressure is more. But whatever the blunt side, that blunt side which covers more area, so that's why the pressure is less. Okay, so this is about the pressure. And what about the thrust? Okay, thrust means, see, for example, see here, now this is a nail surface. Okay, you have to apply force in this direction, correct? In this direction. Now you are applying a force perpendicular to this surface area, correct? You are applying force which is perpendicular to this surface area. So then we can call that force as thrust. Thrust means it's upward force or the perpendicular force. Okay, for example, see, this is a marker. Okay, now I will apply a force, so perpendicular to this surface area, perpendicular to this surface area. So then we can say that is thrust. Now see here, now I will apply force like this. Now I will apply force to this board. Now this is perpendicular, right? So now I am applying that force which is perpendicular to this board. So then we can call that is thrust. Okay. Now take for example, this is a duster. Okay, see here, now I will apply a force. Now this applied force is perpendicular to this surface area, right? Clear? So then we can call this is a thrust. So clear? Thrust means one perpendicular force. It should be perpendicular force to the surface of the area of an object. Okay. So clear, right? Now you can answer, drawing pins, correct? You have seen this kind of drawing pins. See here, drawing pins. Just imagine you will use these pins to for drawing sheet, etc. You will press that button. So here you have to press here, correct? See here, you will apply force through this side. That your entire pressure which moves through this nail, right? So here it covers very less amount of area. So that's why it covers very less amount of area. That's why its pressure is more. So that it will easily move inside that drawing board. Clear? So here, if when an object covers less amount of area, at that time the pressure is more. Okay. So now, now can you give the answer why camels can walk easily on the deserts? Okay. Why? Because see, if you walk on the deserts, it is difficult for you. Why? Because see, our feet which covers less area, so that's why the pressure is more. So means our legs they will move inside the sand. Okay. But camels' feet are wide. They will cover more area. Okay. The feet of the camels, okay, cover more area. So that's why the pressure is less. So that's why camels can walk easily on the deserts. Okay. Yes, sir. See, we have formula to calculate pressure. Okay. So we have formula to calculate pressure. That is thrust. Thrust divided by area. See, what is the thrust? Thrust means it is a force only. That is perpendicular force. Okay, it should be perpendicular to the surface of an object. Okay, and area, how much it area covers. When if it covers more area, then the pressure is less. If it covers less area, then pressure is more. So to calculate pressure, we have formula that is thrust divided by area. Okay. So then what is the SI unit of pressure? How do we measure the thrust? See, thrust means what? Force. We measure force in Newton. Area, we measure area in. Sorry, we measure thrust in Newton, and we measure area in. We measure area in meter square. Okay. So that's why the SI unit of pressure is Newton per meter square. Newton per meter square. So instead of this Newton per meter square, we use Pascal. Okay. So one more result, we instead of this Newton per meter square, we use PA, that is Pascal. Okay, that scientist name Blaise Pascal. So instead of that Newton per meter square, we use Pascal. Okay, so Pascal is the SI unit of pressure. So what is pressure? Pressure means it is a thrust by area. So clear, right? When pressure increases and when pressure decreases. Okay. So thrust means it is a perpendicular force. Okay, perpendicular force, that applied force, if it is perpendicular to the surface of an object, then we can say that force has thrust. See here, now we can discuss one problem. See. Yes, see here, a block of wood is kept on a tabletop. The mass of wooden block is 5 kg and its dimensions are 40, 20, 10 centimeter. Okay, so find the pressure exerted by the wooden block. Find the pressure exerted by the wooden block on the tabletop. If it is made to lie on the tabletop with its sides of dimensions 20 centimeter, 10 centimeter and 40 centimeter into 20 centimeter. Okay, see here, you have to keep that table, that box like this. Just when this is a box. Okay. Yes. See here. First one 20 centimeter and 10 centimeter. Okay. Then second case 40 centimeter and this is 10 centimeter. This is 20. This is 40. So we have to keep that box like this over the table. So now out of these two, okay, first we should keep like this, second like this one. Okay. So now our work is to calculate. So in which position that pressure is more from the table, from the box on that table. Okay. So just observe here. Here it covers less area, correct, but here it covers more area. Okay. So we should show that mathematically. First, see here. First case. First, we should calculate. See here. If you keep like this or like this, okay, that force from this box on that table, which is same. Clear? The force from the box on that table is same. If you keep like this, or like, for example, see here. See, just now this is a table. I will keep over the table like this. If you keep like this or like this or like this, the force from this duster on the table, that is same. Clear? See here. Now this is my hand. I will keep like this. Okay. So now this duster which is applying force on my hand. If you keep like this, or if you keep like this, okay, or if you keep like this, the force from this duster on my hand, that is same. Okay. So first to calculate the force. Force means what it is? Downward force. Okay. Yes, how to calculate that downward force? So for that we have formula to calculate force, that is F is equals to m into g. Okay. So m means mass of the table, that is 5. Then what about the g? G is 9.8, that is acceleration due to gravity. So if you multiply, so then you will get 49 Newton per meter square, or force, right? Just 49 Newton. 49 Newton. Okay. Yes. So now the force is 49 Newton. Right here. So force is equals to 49 Newton. Now, first consider this is first case A and this is B. So now first case, how to calculate area? First we should see, to calculate pressure, we know the formula. See here, that is pressure. Pressure is equal to thrust by area. Correct? So what is thrust? Thrust means downward force. It should be perpendicular to the surface. Correct? Yes, sir. That force is 49 Newton. Okay? This is thrust is equal to force, right? Now calculate area. How to calculate area? So area is equals to, how to calculate area? See now the area 20 to 10 centimeter, right? Yes, how to calculate that area? So that is the length into breadth. I'll write just short form, length into breadth. Okay, because see now this box is covered area like this, 20 centimeter and 10 centimeter. Okay, so what is the length and what is the breadth? So length is 20 centimeter and breadth is 10 centimeter. So 20 into 10. So that is 200. Okay, 200 centimeter square. Clear? 200 centimeter square. Okay. Suppose if you convert into meter, so then convert into meter. So better you can convert here only. Okay. If you convert this one, you will get 0.0. See, if you convert 200 centimeter into meter, so you will get 0.02 meter square. Okay. Or better, we can convert here only. So 20 centimeter, which means that is 0.2 meter into 0.1 meter. If you multiply, you will get 0.02 meter square. So this is the area. Now calculate. So 49 divided by 0.02. Yes, so tell me the answer quick. 49 divided by 0.02. Yes, I am waiting for your answer quick. The answer is 2450 Newton meter square. Yes, correct. So better if you don't know, just multiply here and here 100 and here 100. Okay, so you will get 4900 divided by 2. So the answer is 2450. Okay, 2450 Newton meter square or Pascal. Okay, 2450. Okay, I will write here in this case 2450 Newton meter square. Okay, now calculate second one, second case. See the second case also, the force is same. Clear? But here it covers different area. See here. So first 49 Newton is over. So first we can calculate area. Area is equals to thrust. Thrust means what? It is a perpendicular force. So we have calculated that is 49 Newton. So area equal to thrust by area, right? So length into breadth. Length into breadth. Okay. Yes. First calculate. What is the length? Length is 40 centimeter and breadth is 20 centimeter. Okay. So 40 into 20, so better convert into meter. 0.4 meter into 0.2 meter. So what is the answer? 0.4 into 0.8, that is 0.08 meter square. 0.08 meter square. Okay. Yes. So now we got here, right? Now calculate pressure. Right here, area equal to 0.08 meter square. Okay. Yes. So now pressure is equal to thrust by area. Thrust by area. So what is the thrust? That thrust means that is force. That is 49 divided by area. Area is 0.08. Yes. And the answer. What is the answer? Quick. Yes. The answer is 61. That is 612.5 Newton meter square. Okay. Answer is 612.5 Newton per meter square. Correct. Now just into 100 divided by 100. So which is equal to 4900 divided by 8. So you will get the answer 612.5 Newton meter square. Okay. So this is the force. Clear? Now tell me, see here, when you keep like this, In this position, the dimensions 20 into centimeter. In this case, the pressure from this box is more. But here, the pressure, if you keep like this, here 40 centimeter, 10 centimeter. If you keep in this position, then the pressure is very less. Okay. So clear, right? What do you mean by the pressure and thrust? I think now you can answer why the trucks tires are very wide and why the army and the trucks are very wide, towards more area. Clear? So where if you want to reduce the pressure at that time, so that object it should cover more area. If you want to reduce the pressure at that time, that object it should cover less area. If the area is more, then the pressure is less. If the area is very less, then the pressure is more. Okay. I will stop here. Tomorrow I will continue the class. Thank you.